Auto Discovery VPN. What is it? We're going to learn about what is Auto Discovery VPN, how we can deploy it, and two of the common deployment topologies that we might use with Auto Discovery VPN. So, what is Auto Discovery VPN? Well, simply put, it's a way for two spokes on a Fortinet VPN topology to speak to each other. When they want to speak, they would dynamically create a tunnel between each other, and they would be able to share information through that tunnel. To help us understand this a bit better, I think we could use an example. I know you might remember the game from long ago where we had two cups on a string, and every time we try to speak, we need to make sure that that string there is connected so the other person could hear us clearly. If the string were to burst, then the other person can't hear us. Thankfully today, cell phones aren't like that. So now when we want to call someone, we just dial that person's number. In this case, we're calling Bob. And when we dial Bob's number, we have a tunnel dynamically created between ourselves and Bob so we can speak on the phone together. When we finish speaking and we hang up, the provider cuts our tunnel or connection. Why are we talking about cell phones? Well, to me, the regular VPN topologies are similar to the cups and string approach. They always need to be connected to have the traffic flowing between sites. Auto Discovery VPN is like the invention of the cell phone. Whenever one spoke on the network needs to speak to another spoke, they could dynamically create that tunnel, just like I would have called Bob. And when they're finished speaking and the tunnel isn't needed anymore, the tunnel could be removed. Well, what is the advantage of this deploying Auto Discovery VPN? To see some of the advantages, it might be beneficial to look at some of the drawbacks of the existing VPN topologies. The first one that we'd look at is on your screen there. It's the hub and spoke topology. This topology is great in that it's easy to configure, and we have one VPN tunnel per branch or spoke on the network. The disadvantage with this topology is that all spoke-to-spoke traffic needs to flow through the hub, which could introduce some latency, and we know applications like voice are latency sensitive. The other drawback to this is that there's a single point of failure. So if this router were to go down, then all the branch 1 connectivity would go down. And I'm sure that we don't like having a single point of failure in our network. One way that companies try to deal with this is by deploying a partial mesh, which would help a bit, but the benefits would only be seen by some of the branches, and it isn't very scalable because the more sites we add, the routing could become very complicated using this approach. We could also deploy a full mesh topology where we connect all sites to every other site, which is great, but then again, when we scale, we have a lot of VPN tunnels to manage as we keep adding sites. And if we remember, the FortiGate firewalls are just that, firewalls. Then we also have a lot of policies, if I could spell it. We have a lot of policies to configure to manage all those tunnels on the network. And this is where we can start to see the advantage of the Auto Discovery VPN. The topology here, if we're using a single hub deployment, wouldn't change. We'd still have one hub and 3 spokes. The advantage in this deployment would be that when .20 here tries to speak to .30, the traffic would start off the same way. It would flow between .20 and .30. But then, when the hub sees .20 trying to speak to .30, you would say, hey, you could dynamically create a VPN tunnel between yourself and .30. That's called a shortcut offer. So you would offer him a shortcut. When .20 gets the offer, you would say, why not? And he would send a shortcut query through the hub to .30. The shortcut query would have his local subnet. .30's local subnet is public IP. Let me just clear it so you can see it. And also a dynamically generated pre-shared key. When .30 receives all of that information in the shortcut query, he would say, why not? It would be easier. He would send back a reply including his public IP through the hub to .20. When .20 receives it, then they could dynamically create a VPN tunnel between each other. All other traffic would now pass through this VPN tunnel. And this would happen in a matter of seconds, so only a limited amount of traffic would ever have to flow through the hub. I'm sure you could see some of the benefits of this deployment approach already. It's easier to manage. But you might say, Jeremy, we still have a single point of failure here. We only have one hub on the network. And that's true in this case. But Auto Discovery VPN is a scalable technology. So if we want to use multiple hubs, how would it change? The traffic flow would be very similar. When .20 down here needs to speak to .50 here, the traffic would flow through hub 1 and hub 2, which is .10 and .40. But when the first hub that receives the traffic, being .10, sees .20 going to .50, speaking to another spoke, he would send the shortcut offer. .20 would see the shortcut offer and would send a shortcut query through both hubs all the way to .50. Shortcut query again would have his local subnet, .50's local subnet, or his destination subnet, his public IP, and the dynamically generated pre-shared key. When .50 receives that information, he would reply with his public IP. And let me give you the reply in a different color. He would reply with his public IP. And then they would say, we can now dynamically create a VPN tunnel between us. So the VPN tunnel would be created and all subsequent traffic would flow between these two spokes on the network. Now there's a bit more to understand about the deployment of the Auto Discovery VPN, but we'll cover that in another video.